So apparently I missed the last example on page 2. We'll just add to page 3. It's not a big deal. Again, this is a problem-solving kind of thing. So we have a sphere, a beach ball. Okay? It's round, a circle across the middle here. I want to know its diameter. I want to know how far it is across that circle. Okay? To do that, I got to use the information we're given. We were told that the surface area from our formula sheet is 4 pi r squared. And in this particular case, it told us that the surface area is 2,827. 4 pi r squared. I don't know the radius. Kind of know that. If I know the radius, I can find the diameter. This is, again, an algebraic problem that we can solve. Let's do math where we can do math. 2827, I can't really do anything with that, but I can figure out what 4 times pi is. It's 12.57 with an r squared attached to it this time. Last time we just had the h attached to it. If I want to know what r is, I can divide out 12.57 from both sides. And I'll be left with just r squared on the right hand here. On the left hand side, I'll end up with 224.97. That's what r squared is. Just like Pythagoras here, if I want to figure out r, I can square root this thing. And it turns out that r is approximately, rounded, 15 centimeters. Well, if I know my radius, my diameter is just 2 of those, right? My diameter is 2 times 15, or in other words, it's got to be 30 centimeters. Okay? So again, a second example where we can problem solve by filling in the parts and pieces that we actually know. Okay, the last example. Okay, we got Steve, who's mowing the lawn, ran over his garden hose, cut it in half. Okay, so this is, I guess, half of it right here. Tried to glue it back together so we wouldn't get in trouble. Okay, you want to apply a layer of glue to each end of the cut. So even though we only have one end showing here, the other end would look basically the same, right? He's got to try and glue in here. Okay, so we got to figure out how much glue would go there. The hose has an outer diameter of 4. So top to bottom, this would be 4 centimeters. That's my diameter, which means my radius would be 2, right? And the inside diameter, this part in the middle here, from here down to about there, is 3.5 centimeters. So again, our radius, half of that, 1.5 centimeters. Okay. We got to put glue on this thing. Now, it's a three-dimensional picture, but it's not necessarily a three-dimensional problem. Okay. That flat surface we're actually putting the glue on is a two-dimensional surface. Okay. And this kind of looks like one of the questions we did yesterday, where I want to find a shaded region. And we said yesterday, if I want to find a shaded region, I can take the outside minus the inside, and the part in between will be what's left over, right? We did the one yesterday with a square, and we had a circle inside. Okay, the outside shape, we want the circle, pi r squared. The inside shape is the circle also. The outside shape has a radius of 2. The inside shape has a radius of 1.75. Okay, make sure we're squaring both of those two things. And when I calculate this, I get for the outside circle a total of 12.57 and the inside 9.62. Subtract them, find the difference, the shaded region, if you will. I get 9.5 centimeters squared. Now remember, that's one end of the hose. So if I want to know the total amount of glue, we need both ends, so 2 each. 2.95 will give us a total of 5.9 centimeters squared. The trick to notice here is that even when you're dealing with three-dimensional shapes, sometimes it's a two-dimensional idea. And that will take you to the end of surface area. Give the homework a try. Some of them take a little bit of practice, yes, but the lessons from here on get a little bit shorter.